Today we'll be solving uh, one physics problem, which is from H.C. Verma, chapter 3. Um, so let's start with the problem. So what the problem says is the man has to go 50-meter due north, 50-meter due east, and 20-meter due south to reach a field. What distance he has to walk to reach the field? So what we'll do, we'll first define what's east, west, north, south. So the upper direction, I am assuming it's north. The downward direction is south. The direction to the east, to the right is east, and the direction to the left is west. So now, first let's solve part A. Let's assume I am the man and I am starting from here. So I'm going 40 meters, 50 meters to north, right? So this is my stop one. Then I go 40 meters to east. So this is my stop two, and this is 40 meters, right? And now uh, I go uh, 20 meters south. So yeah, this is not to the scale, but uh, approximately this is my stop 3 and this is my destination. This is where I reach after doing this maneuver. So the first part asks us what's the distance he has to walk to reach the field. So basically, uh, so as we know, distance is a scalar quantity, and for distance we just have to add how much amount of distance we had walked. So it will be distance s1 from s to s1. Then we also have to add distance from s to s2. Then we also have to add distance from s2 to s3. So the total distance that the man has moved will be the addition of these three distances. So it will be 50 plus 40 plus 20, which comes to around 110 meters. So the distance traveled by the man is 110 meters. So now let's go to part B. What is the displacement from this house to the field? So as we know that displacement is a vector quantity. Uh, so we can't directly add these three distances as we added while calculating the distance. Uh, like we have to calculate displacement, but we can add as we added in the displacement. So let's say, um, okay. So as it's a vector quantity, we have to do a vector addition instead of a scalar addition. So I'm putting bars which will represent that these three are just like a vectors and not a scalar. Um, okay, you can use a few formulas here, but I will let you know the shortest path. So let's assume I can shift this 40 meters here, and completing this rectangle, this will also be 40 and this will be 20. So the remaining distance from here, let's say this is point P, is 30. So now intuitively, this should be the displacement. So I can rewrite this as displacement from S to P plus displacement from P to S3, right? And yeah, so this seems pretty obvious as we have one side as 40 and one side as 30. So we know like 30, 40, 50 are Pythagoras triplets. So displacement should be of 50 in magnitude. Remember, displacement is a vector, so it would have a magnitude as well as a direction. While in A part, distance is a scalar, so it will only have a magnitude part, no direction. And yeah, so we can calculate some angles from this side. It would be something like tan inverse tan inverse, it would be 4 by 3 due to due like you can say from north, due north from east. Yeah. So thank you. This is the today's video. I will just summarize what we have learned. So the key thing that we had learned, one is distance is a scalar quantity, and another thing we have learned is displacement is a vector quantity, and it's that we just added the distances as a scalar to find the distance. We added them as a vector to find the displacement. So that's it for today, guys. If you have any doubts, let me know in the